Hi, my name is Maciej Kaczkowski. I'm a machine learning engineer at deepsense.ai, and today I will discuss LLM-as-a-Judge, so from BLEU to G-Eval, its motivation, techniques, and limitations. There will be four main parts of this talk. First is a simple and quick introduction. Then we will discuss why do we actually need these solutions, and then we'll discuss specific methods and like the nitty-gritty details of implementation. And then we'll discuss some common pitfalls and limitations which you need to be aware of. So first of all, actually, why do we need this evaluation thing? Because obviously you may find yourself being like this rabbit, very confused with a lot of magic dashboard and nothing really makes sense. So the question is it worth it? Why do we need to spend so much time and effort and so much things you need to consider while doing this evaluation? And the reason is quite simple, because the GenAI solutions are very quick to like have POC or some simple products, but then scaling it up and making it actually successful project in a business sense, but also as a long-term solution, it's very difficult. The MIT report showed that there is like a 75 to 95% chance of failure, basically. And one of the things you can implement or things to consider to prevent your project from falling into this majority which fails is actually evaluating it and checking if it really solves the problem you are trying to solve. Obviously, this is not very easy and not that trivial, but worth it. And if there is a single picture you need to remember from this talk is this one. So basically, the LLM-as-a-Judge uses LLM, large language models, to judge outputs of some other models. And there are a couple ways you can do it, but this is the basic idea that you can use the large language models as semantic evaluators instead of using basic NLP techniques like BLEU, which are not really feasible in this case because they focus on string similarities or very basic metrics, and they really are not very good at comprehending what the string, the sentence actually means. So that's why we need these LLMs, and they may have their problems, but for this case, they are pretty good actually. So now more about the motivation. There are three things which we need to consider. First is the LLM-based solutions, which needs this evaluation, are getting more and more prevalent. Then that there are lots of metrics you kind of can use, but most of them don't really make sense in most use cases. And then last thing you can think of is human evaluation, but it doesn't really work actually. And first thing about this prevalence is very simple Google search, and it shows that there is lots of articles, lots of things that are happening in this space. So it's pretty much self-evident that the solutions are getting more and more adoption. So how do we actually measure them? We can follow this very simple example when the question is who went up the tree, with the dog chasing the cat up the tree, and our system actually answers correctly, it's cat, but the reference value is dcat for some reason, because the developer chose this as a ground truth. So then we can calculate word error rate and character error rate and get values like this, which means very bad, basically, that all words are not correct because there is D cat and cat, which is capital cat. These are different words. And if we calculate just the characters, it also means that most of them are wrong because one sequence of characters is 7 characters and one is 3. And obviously there is this weird feeling that they actually mean the same, and it's a very simple question, but the metrics cannot really comprehend them. We can be more sophisticated and use BLEU or ROUGE or other metrics like this. They are basically a little more complex, but the problem is that they still don't give really good answers. In this case, the lower the worse. So we get 0, and okay, we get precision, but we don't really get any meaningful knowledge from this because recall is still poor and F1 score is not really helpful at all. So we can move to this, the opposite side of the spectrum, which is, okay, let's take a bunch of humans and put them in some workspace, some hall basically, and make them evaluate our answers of our system. But then we quickly end up trying to scale it, and obviously we need another bunch of humans with another hall, and it doesn't really make sense. Second thing is that the quality will likely be better, but not always, not that much, because it's pretty hard to find qualified humans, so to say. So they won't make this like very weird mistakes, but they will also make mistakes themselves. They are prone to biases. They can be tired, and obviously it's not good idea perhaps to have people do this kind of jobs. And also it's slow. So think of it as a CI/CD pipeline or something, but your pipeline is basically some human doing this evaluation. You need to wait, and it's the more prompts, the more answers you have, it will degrade very quickly. So how do we actually combat this? We have a bunch of ways, and to start up, I will ask this question and try to answer it later. Who judges the judges? So how does this happen that LLMs can actually judge other LLMs and the judgment makes sense, it's better, or it provides some new information? There are a few ways we can achieve this, and I will quickly discuss them right now. This is we can basically have 2 types of this eval, single output and pairwise. We can still have some problems which we can combat, like not having any quantifiable answers, like scale from 1 to 5. We can actually achieve this. But also there are biases and errors which LLMs can produce. I will discuss them briefly later, but now it's very quickly just narcissistic bias or verbosity bias. And there are some tools which we can use out of the box, which I will discuss also in this section. So the main framework, so to say, we may use is G-Eval. It was introduced in this paper, G-Eval and LG evaluation using GPT with better human alignment. And the basic goal of this paper is to provide eval systems such that the answers achieve high alignment with humans. So this is what we wanted, because now it's automated, it's less error prone, but it still makes sense, and the judgment is very similar to what we will do. So first thing we need to have is task introduction. This is just this brief goal statement for the judge. Then there is evaluation criteria, and this is a crucial part because it allows us to custom define what we actually need. And for example, we may need coherence, we may need similarity, we may need other correctness, other metrics, which are very difficult to actually emulate using, for example, word error rate, like summarization. It wouldn't really work. But here we can just define it, define the scale, and define like English description of what this actually means for us. And it will basically work because LLMs can process this. Then the judge creates his evaluation steps using chain of thought technique, which is basically self-instruction for the judge to actually process the input in a correct manner using this evaluation criteria we provided, and also the main task goal. Then there is input, and this may be a simple input target, but this may also contain a very useful context, like if we have some RAG pipeline or some other additional context the judged model uses. The judge actually also can get this, and for example, he may test if the knowledge which model actually provided is and for example cited some articles, is it really in this article? It may be separately checked, and this is also one of the important let's say cruxes, that you need separation of concerns so that the judge is not affected by other things. And the goal of this model is to just check if the answer matches the evaluation criteria. And then as an output, we obviously get this scores in given categories. This is really useful because now we can do something like average this, or do some other normal math, and it will allow us, for example, to check whether our model new released system improved or not really improved the quality. So this allows us to have this quantifiable results out of the pipelines, which are also human aligned. This is main thing of which G-Eval proposes. So first thing we need also to consider is a very simple single output evaluation. This looks like this on the picture. There is one LLM which is answering and one which is being used as a judge. So this is very simple schema how this works. Obviously the prompt is simplified, and using G-Eval it will be much more complex, but the main idea is like this. So we define this criteria, and this is very crucial, as I've said earlier, that the criterion are actually what we want to achieve. It's kind of a business logic in a sense. So we can easily, in plain English, identify and provide the model with criterions, which is very useful. But also the criterions needs to be good, obviously, because the model cannot tell if they make sense or not. It's our job as a human. Still, there are biases, which I will discuss later. It's actually very interesting that models are like narcissistic in a way. And we can think of it as a grading problem. So obviously we can have lots of scales, and actually the authors of this source blog, which I used here, actually proposes binary scale sometimes, most of the time, but it's also so to say a judgment problem, that we need to know what actually do we want to achieve. Is it like a customer with this stars feedback? There is 1 star, 2 star, and so on and so forth. Or do we actually need the model to be judging, for example, if the answer is safe, if the answer is not, I don't know, harmful in any way? Then it's binary scale probably, and this is also something which we need to consider while developing these systems. Another way we can use this judge is pairwise evaluation. It looks like this. So basically, the judge just selects which model performed better. And this is the schema. So now we have two answers, basically, and the judge selects the one which is better. And this is really interesting. In the paper, so LLM-as-a-Judge, it was actually shown that it's highly aligned with humans. So the LLM arena uses this. It works very similar on this site. Also, if you're familiar with genetic algorithms, it's kind of like a tournament selection in the end process of generation. So after the genetic algorithms perform some changes in the population, then there is a selection which basically tells us which vectors or which I don't know, data points are going to be selected to the next round, and this is very similar to this. So you don't actually need to know if the answer is good or not, but you can certainly tell if it's better or worse than the other. And this method allows surprisingly high coherence with human answers. I think the authors were claiming about 95+%, so very, very good results actually. And here are some example tools. Obviously, the prompt you define yourself, but here we just, for example, check correctness, and the templates are filled with the proper context, so very simple. We can also use like pre-built G-Eval from this library I've mentioned, I've shown on the slide. And this works very similar to PyTest test cases. So if you are familiar with them, probably you are, you will have very easy experience with this library. So here we just define metrics like the evaluation criterion with proper inputs and outputs and the actual definition. And then we can just use this test case to test input output, and actually it provides us with very simple way of generating more or pruning the test cases as in normal PyTest workflow. So now we have discussed the cool parts, which is why is it helpful and how does this actually work, but there are some obvious pitfalls which you can fall into, and I hope I will warn you from them, and also limitations of the whole system, because as I've said earlier, the judging by other LLMs works pretty well, but it's still LLMs judging LLMs, so most of the time you also still need some sanity check in the process. So what are the limitations? I've identified, let's say, 3 main limitations. 2 of them are intrinsic LLM properties, it seems, so the narcissism and the verbosity. Then the third one is actually the, so to say, system problem. So when developing a system, you need to think of it as a whole, not just the generation part. And I will also discuss it later. So moving to narcissistic evaluators, the paper LLMs are narcissistic evaluators when Ego inflates evaluation score, shown that our judges, they tend to give better results to the answers generated by themselves or the models from their family. So it's kind of funny, but apparently the LLMs prefer their own kin, and you need to take this into account and perhaps do some normalization or some weighting or averaging the scores to avoid the thing that I don't know, some provider A prefers answers from model A, and this is not this is probably not like explicit in the model's training that you need to prefer your family of models basically, but it's likely implicit property because the models are trained in a certain way, they answer in a certain way, and the answers are some way similar between in these families of models like GPT or Claude or something, and they probably are better aligned with themselves, so to speak, which is weird and funny, but it makes sense. Then another problem which you are probably familiar with is that LLMs are overly talkative. They often prefer the long and elaborate answer to quick answer, and the verbosity bias paper showed this as a alignment distribution with the observation that the human alignment was worse when in cases where humans prefer shorter answers. So basically this means that models still gave the longer answers, but the human would just prefer, I don't know, 1 sentence, 2 sentence, 3 sentence. And we can combat this actually by using custom metrics, which is like brevity metric, brevity soul of wit. So the models can be like explicitly taught to not be that talkative, or the judges to prefer actually shorter answers sometimes, because obviously there is value in the fact that LLMs can quickly, I don't know, draft your email or draft your presentation or draft your document, but the problem still persists that it's not really feasible, and sometimes you just need a quick answer. So then you need this custom eval probably. And the third problem, which is very very big topic, and it's not that easy to solve in my opinion. But if you look at the RAG pipeline from Hugging Face, for example, this evaluation cookbook they have, is that actually you need this you need to evaluate the whole system. So perhaps your data governance is poor, and your knowledge base in your organization or what you are developing it doesn't really work. It's messy, it's not organized. So then everything which comes after will also be probably of poor quality. So perhaps you need to improve data governance. Then there is a data ingestion pipeline, which basically means that you need to chunk your documents and ingest them into vector database, which is probably not that hard, but it's also hard to do it well so that it won't affect quality of the next things in the pipeline. So this is a second problem, and we are not even in production. It's just creating vector database. So perhaps you need better data ingestion pipeline. Then there is a reranker, which basically after you retrieve these vectors, then they are re-ranked to better match what is actually expected. And also you can swap re-rankers. You need to figure out for yourselves which is best for your use case. Then there is context building. So the whole thing you also provide to LLMs, this generative part of the pipeline. And it also needs to be, explicit enough and contain enough information, because obviously if you don't have this information, you won't get them in the answer, or worse, you may get some hallucinations. But also probably you are using some paid providers, you're paying per token, so you need to be smart with this context, because obviously you don't want to spend too much money on this, more than it's needed. And then only after we get to this final step, which is generation, which is what the user sees. And this basically means that your chatbot answers, and your I don't know, your whatever product using LLM is properly utilized. And here you can use this evals for generation evaluation, but nothing of this will work probably, right, if you don't have these previous parts set up in order. So you need to be also aware of this fact. So key takeaways and basically summary of this talk. First of all, there is a pretty well established tooling and theory behind using this LLM-as-a-Judge framework. And key thing is separating the tasks between the models, so that one model is acting as a judge, one model is doing some, I don't know, reasoning, and one is doing some other things, but they are separated. The other, let's say, advice I would say is using this single output, the simplest of them, as basically your go-to framework. But it will work if the judge is more capable than the model which is being judged. And this is often the case when you have some memory constraints, or you want to use smaller models to be smarter, to only like extract key things, key features from the let's say your product. But then you, during evaluation, you have this access to larger model, and it also works pretty well. Pairwise evaluation may be used as something similar to A/B tests, when you just define your key metrics, or what you actually want to test, some clients engagement things, and then you just test them, and you compare this with pairwise evaluation. So then now you know if your judge is actually aligned with your market, let's say, or your clients, or the judge actually makes correct decisions. And it's like very similar to A/B tests, so it may be matched. Then there are two problems which you may bump into, which is verbosity and narcissistic bias. But for most of them, you can use this evaluation criterion set, which is, for example, punishing the models for being too talkative, and being explicit, and brevity maybe like rewarded. So this is how you combat those. Last thing is that, as with RAG, there is a system thinking involved, which means that the LLM-as-a-Judge is probably not only metric you should use, but more like part of your evaluation, and you probably still need some human sanity check in this, or other metrics like in normal, so to say, web metrics, performance metrics, database usage metrics, cost metrics. So this is like one brick you can put in your whole building, and it will likely improve it. Yeah, so these are the 5 takeaways, and thank you for your attention.